Right, so we're going to take a look at our last chapter of material for this part of the class, which is chapter 11. There's several sections. We're not doing them all. We're just doing 11.1 and 11.2. Okay, so the first section is on what we call sequences. So a sequence of numbers is it's basically just a list of numbers. It can't be random. There has to be some kind of pattern to it, or some way to be able to predict what the next one would be. So what they usually do is they'll give you some kind of formula, and that formula will help you to predict the next term. Okay? If they don't give you a formula, sometimes that's the goal of the question, figure out a formula to predict the next term. Okay? So here's a sequence of numbers. Generally, we name a sequence with a lowercase letter, English letter. And the first term in the sequence uses a 1 as a subscript. The second term uses a 2. Okay? So if I wrote down like B sub 8, that means I'm asking for the 8th term in sequence B. If you want to know the nth term, this is how you would write it. The nth term just represents a term farther down. We don't know the exact position of it, but it's somewhere further down in the pattern. Okay, B sub n. And a lot of times that's what the goal is. Figure out a pattern for the nth term. So if I said to you what would be the 56th term in this pattern, I would like an easy way to figure out what that term is. In order for a sequence to be unique, again, there has to be some kind of rule, pattern, or formula that's giving you the terms. Okay, they can't be random. There's some pattern that's generating them. Okay, for some formulas, the pattern is very easy to figure out. Other formulas, the pattern can be extremely complicated. So we're going to look at a sequence in a minute, and I just want to see if we can figure out what the pattern is. And based on that pattern, can we find a formula to figure out more of the numbers in the pattern? Okay, so there's our sequence. Generally, if they want you to figure out something about a sequence, they'll give you the first 3 or 4 numbers in it. That's usually enough to be able to figure out the pattern. If you only have the first 1 or 2 numbers in a sequence, no, that's not enough. So if I did something like just 2 and 5, well, the pattern could be that you're adding 3, or the pattern could be maybe you're multiplying by 2.5 each time. You don't know. Okay, so we gotta have enough numbers in the sequence to be able to figure out the pattern. When a sequence ends with ... that means that it goes on forever. It means it's infinite. If a sequence doesn't end with ... then that means it has an ending point. It means it stops somewhere. Okay. So let's see if we can figure out a pattern. Okay. Anyone think they see what the pattern is here? Yeah?
With every number it increases by 3.
Okay, so can you explain more about what you're adding 3 to?
2.
Adding, that's one specific time, yes.
So it's adding 3 to the previous number.
Yes, it's adding 3 to the previous number. So if this is the number that I want to find, anyone have a guess how you would write the one before that one?
(n-1).
Yep. This means to find a certain term in the sequence, take the one that comes before it, that's what the -1 does, and then add 3. So that is a formula for this sequence. So if I wanted to know, let's say, the fourth term, fill in 4 for n, I would take the 4 minus 1, which is the third term, and add 3. That's the formula for the fourth term. And in this case, we know the third term. The third term is an 8, and if we add 3 to it, we get 11. Now, what if I wanted to find, let's say, the 73rd term? What would be the formula for the 73rd term? You don't have to tell me the 73rd term. Just tell me how you would figure it out.
A72 plus 3.
A sub what?
A72 plus 3.
A sub 72 plus 3. Okay, so you'd have to find the one that comes before it and then add 3. Okay. Do we know the 72nd term in what I gave you? No. Okay, so we got to figure out the 72nd term. What's the formula for the 72nd term?
A sub 71 plus 3.
A sub 71 plus 3. Okay. Do we know the 70? So we're trying to find the 72nd term. Do we know the 71st term? No. So now we got to find the 71st term. Okay, this is going to go on for a while. Okay. The problem with this formula is it depends on the one before it plus 3. So if you don't know the one before it, that formula isn't very helpful. Okay. But it is a formula. It's just not that useful. Let's look at it a different way. Okay. What I've written in purple is the position of each of those numbers. The 2 is in position 1, the 5 is in the second spot, the 8 in the third, and 11 in the fourth spot. What I want to look at is there something you can do to 4 that would turn it into 11? And then is there something you could do to 3 that would turn it into 8? So I'm looking for something I can do to the number in purple to turn it into the number in black.
Times 3 minus 1.
Yeah, if you times it by 3 and then you minus 1 from it, it'll take the number up here and turn it into the number down here. So times that by 3, you get 6. Minus 1, you get 5. Times that by 3, you get 12. Minus 1, you get 11. So knowing that you can times 3 and minus 1, that's another formula. So to get the nth term, take the position of the term that you want to know. So we'll just call that n. Times it by 3, and then minus 1 from it. So now if I asked you to find, let's say, the 100th term, you don't have to find the 99th term and then add 3. And then since you don't know the 99th term, then you got to find the 98th term. All we have to do is plug in 100, triple it, and minus 1, and that will tell me the 100th term. So what would the 100th term be here? 299. Yeah. So this type of formula on the right is much better than the formula on the left. The one on the left is called recursive. The one on the right is called explicit. A lot of times a recursive formula is easier to figure out because you just have to look at the pattern and see what you add each time. But it's not as useful. Okay. And I'll write down those two names, recursive and explicit, in a little bit. Okay. And there are ways to figure out these formulas. If the pattern is just a simple addition each time, then we can figure out that formula pretty easily. If the pattern started to get extremely complicated, like you have to take your number, you have to square it, and then add 5 times the number, and then minus 13 from it. Well, that's a little bit harder of a pattern to figure out than just triple at minus 1. That's an easy pattern. So we don't get into the patterns that get really complex. All right, so let's think about that formula we just had here. It was 3n minus 1, I think. There are values you can plug in for n, but there's a limit to it. Okay? N represents a position. Okay? Think about like people finishing a race in different positions. What kind of numbers would make sense for the places that people could finish in a race? Positive, right? You're not going to have somebody finishing in negative 3rd position or negative 10th position. You don't do that. You also don't do 0. Nobody finishes in 0th position. What else besides just being positive? Yep.
They're integers.
Right, they have to be integers. Okay, nobody finishes a race in like 2.3rd place. You know, 2nd place, 3rd place. There's nothing in between 2nd and 3rd place. Well, that's the same when we're looking for numbers in a sequence. You have a number in the first spot, you have a number in the second spot. There's nothing between the first spot and the second spot. So that's why if you have a formula like that, and you're using it to predict terms in a sequence, when you fill in a number for n, you can only fill in a positive number, and it cannot be a decimal. Okay, the number you fill in has to represent a position in a sequence, like somebody finishing a race. Okay, it's a place. Okay, and if it's infinite, then you can plug in any number you want for n. As high of a positive integer as you want to go. There's no limit. But if there is a limit, then we call that a finite sequence. Like let's say this was your sequence, and there were numbers in each of those spots. The highest position in that sequence is position 5. You can't plug 6 into the formula because there is no 6th position. It's like if 5 people were running a race and you asked who finishes in 6th place. That doesn't happen. Right? There's only 5 spots. So if you have a sequence that has an end to it, then that means you cannot plug in as high of a number as you want in the formula. There will be an upper limit. Maybe it's 20, maybe it's 30. Depends on how many numbers in the sequence. But there's a fixed positive value that is the highest, and it doesn't go beyond that. Okay, so finite has an end to it. Infinite goes on forever. Anybody still needs to copy down the difference between infinite and finite? Okay. So let's practice listing terms in a sequence. So this is the kind of problem where they give you a formula, and they ask you to list out some terms. In this particular one, they want the first 3 terms and the 15th term. Okay, so let's start with the first term. To find the first term, they give us a formula. Can anybody tell me what number are we going to plug into the formula to get the first term? 1. Yeah, we're going to plug in 1. So let's fill in 1 for n. What's 1 squared? 1. And what's 1 minus 1? 0. And then we'd have 0 in the top. We'd have 1 in the bottom. What's 0 divided by 1? When 0's in the bottom, it's undefined. The only way you would get 1 in a fraction is if the top and the bottom are the same.
Well, which is 0.
0, yeah. 0 divided by 1 is 0. Okay, and on a test, if you leave it as 0 divided by 1, you're not going to get credit for that, because I don't know if you know what 0 divided by 1 is. Okay, so make sure you simplify it as much as you can. All right, so that's the first term in this sequence, 0. All right, let's find the second term. Jaden, what would we plug in to find the second term in our sequence?
You plug in 2 to n.
Yeah, we'll plug in 2 for n. So when we plug in 2, what's 2 squared? 4 minus 1?
3.
So 3, and we're plugging in 2. That's fine because 3 halves doesn't simplify unless you change it to a decimal. So we can leave it as 3 halves. Okay, and third term. Serenity, what are we plugging in for the third term? 3. What's 3 squared? 9 minus 1?
8.
So 8 thirds. Okay, this would be a hard pattern to figure out yourself, okay, if they didn't give you this formula, because you have to take the number, square it, minus 1 from it, and then divide it by itself. That's a lot of steps. That'd be a tough one to figure out. Okay, and now we want the 15th term. Okay, so 15th term. Gianna, what are we going to plug in for n to find the 15th term? 15. So 15 squared is 225, minus 1 is 224, and we're going to divide by 15. Okay, nice thing about that formula is I was able to jump right to the 15th term. I didn't have to find the 14th, 13th, 12th, 11, 10, 9, 8, 7, 6, 5, 4. Okay. With an explicit formula, you can jump to finding any term you want. With recursive, you can't. If I asked you for the 15th term and I gave you a recursive formula, you have to find every single term up to the 15th one. Okay, let's try this one. So the name, actually you tell me, what's the name of this sequence? B. Yep, the first one was sequence A. This is sequence B. So they want us, again, same directions, find the first 3 terms and the 15th term. So Kim, what are we going to plug in to find the first term? So think about like people finishing a race. Is there a 0th place when somebody does a race? No. What would be the, if you beat everybody else in the race, that would be 1, right? Position 1. So the first thing you can plug in is 1. So we're going to do -1 to the 1 times 2 to the 1. Lucas, what's -1 to the first power?
-1.
So it's -1, and what's 2 to the first power?
2.
2. What's -1 times 2?
-2.
-2. I didn't say anything about the terms themselves being negative. That's fine. -2 is the first term. That's perfectly fine. Okay. Second term. Quinn, what are we going to plug in to find the second term? 2. So we got -1 squared times 2 squared. And what's that going to come out to?
5.
What's -1 squared?
1.
1. What's 2 squared?
4.
What's 1 times 4?
Oh. 4.
4.
Okay.
Yeah. Okay, so there's our second term. And third term. So we're going to figure out first what number we're going to plug in. Madison, what do we plug in to get the third term? 3. So we've got -1 to the third times 2 to the third. Jaden, what's that going to come out to?
-8.
-8. Okay, so notice what's happening here. These terms are alternating positive, negative every other term. Any odd term in this sequence is a negative. All the even terms are going to be a positive. And the reason that's happening is because of what I just circled in purple. -1 to the n is causing this sequence to alternate. And the 2 to the n is causing it to double each time. So that's what happens. It doubles and switches sign. Okay, so b to the 15th power. Okay, first of all, is it going to be a positive or a negative term? Yeah, it's going to be a negative. All the odd ones are going to be negative. So we could just put the negative right there. That takes care of negative 1 to the 15th power. It's just a negative 1. And then we need 2 to the 15th. Now, when we're doing this out, if the number starts to get really big, like it starts to get into the billions or trillions, we probably won't do it out. But 2 to the 15th power, we will do that out. All right, so let's raise 2 to the 15th power, and we get 32,768. Don't forget that there is a negative in front. That's definitely small enough that I would still expect you to do that out. Okay. If it was like 2 to the 50th power, no, that's getting kind of big. Okay. Any questions on that? All right, so the two formulas that I've given you here, formula for sequence A and sequence B, are both what we call explicit formulas. That's the best kind of formula to have. Explicit formulas allow you to calculate any term in the sequence you want directly. So you want to know the 300th term, you can just find the 300th term. If you didn't have an explicit formula, we would have what's called a recursive formula. I said before, recursive is easier to figure out, but it's not as useful. If you want to know the 300th term in a recursive, using a recursive formula, you need to know the 299th term. And to figure out the 299th term, you need the 298th term. So you'd need every single term from 300 all the way back to the beginning. Why would that be kind of a pain, to use a recursive formula to find the 300th term?
So you have to figure out all of the ones up to 300.
You got to figure them all out. There's a lot of, you can take a lot of time, even if it's a simple formula. Doing something simple 300 times, it's still going to take a long time. And it's very easy to make a mistake. If you make one mistake early on in the sequence, everything else after that is going to be messed up. Kind of like when you're, if you're building a wall out of bricks. You got to make sure every course is level, because if the bottom one isn't level, then every course after that isn't going to be level. So you got to make sure that it's correct each time you go. All right, so we generally kind of want to stay away from recursive formulas, unless they specifically ask us to find a recursive formula, then we will. But given the choice, we should pick a explicit. The other thing is, in a recursive formula, I have to give you the first few terms in the sequence. Generally, the first 2, 3, 4 terms. In an explicit formula, I don't have to do that. I can just say to you, here's my formula. And that's it. I don't have to tell you the first term. You can figure out the first term. Plug in 1 for n, and you'll have it. But if I don't give you anything in a recursive formula, you wouldn't know where to start. So I have to give you something to start with. Okay, so here's an example of a recursive formula. What is that basically saying to do? If you just had to explain this in words to someone in a simple way as you can. It's based, how do you get the next term? What are you doing? Yep.
Just go to the previous number and add 3.
Right. This is just saying go to the previous number and add 3. That's the pattern. So if I didn't give you the first number, well, how would you know what to start with? I'm asking you to find the second term. I'm giving you the first term, and I'm telling you what to do to it. So using that recursive formula, what would be the second term in this sequence? 5. And the third term? 8. Right, It's not that bad if you only have to figure out a couple of them. But if you want to get to the 657th term, well, I don't want to keep adding 3. That's going to take a long time. Okay. So any question on the difference between explicit and recursive?
Is there ever going to be questions where you're going to give us recursive formulas? We have to figure out the explicit version.
Yes. Yep. We'll look at, so here's one, yeah, right here. So I'm giving you a recursive formula, add 5 to the term that comes before it, and I want you to convert it to explicit.
Okay.
All right, so let's try this one. We're not finding a formula here. This time they just say determine the first 4 terms and the 8th term. Okay, we know it's a recursive formula because we see something like this. Whenever you see a sub n minus 1 or minus 2, minus 1 means to go back to the one before and do something to it. If you saw a minus 2, that means you need to go back 2 terms and do something to that one. Okay. But either way, they're both recursive. Okay, so let's figure out, I think I made a chart right here. So the chart's got the position, and I've got the term in that position. Okay. What's the term in the first spot? 2. How do we know that? Yeah, it's given. In a recursive formula, there's no calculating the first term. It will be given. If it's not, you can't do it. Okay. How about second term? 6. Okay. It says to add 4 to the previous term. So we've got the first, second, what's the third one?
10.
And the fourth one. Okay. That's the group of terms they wanted together. Now we want to jump to the 8th term. In a recursive formula, can we jump to it? No. Even though they don't want the 5th, 6th, and 7th, we need to find the 5th, 6th, and 7th. So what's the 5th term? 6th term? And 7th? Okay, now if we made any mistakes in there, now the 8th term is probably going to be wrong. But I think everything looks good. So what's the 8th term? 30. Okay. So here's the first 4 and the 8th. Okay. Any questions on that? All right, so now I'm going to give you a recursive formula, and I want to see if we can change it to explicit. You're adding 5 over and over. Okay, that's the pattern. You add 5 to the one that comes before to get the one that you want. The number that you're adding over and over is going to be part of the explicit formula. So like earlier, I gave you guys a formula, and I asked you to make it explicit. We were adding 3 each time to get from one to the next, and 3 was part of the formula. So a lot of times it's going to end up being times something plus or minus something. Okay? Those will be about the difficulty of the ones I would have you figure out. Okay. So they want you to convert this to explicit, and my suggestion is write out the first 3 or 4 terms. Okay? If you write them out, you'll start to be able to see a pattern. Okay, so write out the first 3 or 4, and then we'll give you guys a minute to try that. We'll see if we can figure out the explicit formula. Okay. So explicit formula is going to be something like a sub n equals, and then it's probably going to be something like a number times something plus or minus something. Okay. So just take a minute and see if you can figure that out. All right, so let's list out the first couple terms. And what do we get for the second term? 8. Yep. And the third term? And say it again? 13. Yeah, did you say 14? Oh. Okay, so at least now we've got an idea when we find a formula if it's working, because we got a few things we can try out. All right, so now the goal is to figure out what can you do to the number that's circled in purple to turn it into the number on the right-hand side. And since you're adding 5 each time, it has something to do with 5. Anybody think that they saw a pattern? Yeah?
I did the number circled in purple times 5 and then minus 2.
Yeah, so the number circled in purple, that we're going to call that n. That's the position that we're trying to find. So the nth term in our sequence, if you take the position, multiply it by 5, and then minus 2, 5n minus 2, that should be your formula. So let's try it. If we want to find the third term, what's 5 times 3? 15 minus 2. 13, perfect. Let's try it on the second one. What's 5 times 2? 10, and 10 minus 2? 8, perfect. So now if we wanted to find any term, so you want to know the 100th term, 5 times 100 is 500. 500 minus 2, 498. Very easy to find the 100th term, even though it's really far down in our sequence. So any question on that? And if you weren't sure, like how could you figure out times 5 and minus 2 in a more mechanical way? We'll talk about how to do that. Okay, there is a set of steps you could follow that would give you that formula. Okay, let's try this one. So this is another recursive sequence. Okay, it's one that's pretty well known. It's called the Fibonacci sequence. And the Fibonacci sequence is a little bit different than the recursive ones we've done so far, because it not only depends on the term right before the one you want, it also depends on the one before that. Okay. Okay, so what this pattern is basically saying is to find any term in the sequence, take the previous 2 terms and add them together. This is not an easy formula to find an explicit version of. Okay, this one is pretty hard. Okay, so we got our first 2 terms, 1 and 1. If the pattern is to add the 2 together that came before it, what do you think the next term would be? 2. Yep. And the next term after that?
3.
1 and 2 gives you 3. 5. And how about 3 and 3 plus 5? 8. So we just have to figure out how many do they want to know. The first 6? That's the first 6. Okay, so any questions on figuring out the terms in a Fibonacci sequence using a recursive formula? Okay. And if you look up Fibonacci sequence, there's all kinds of places you see that come up. In nature, there's like lots of patterns that involve that sequence, so it does come up a lot. All right, so last thing we're going to look at are 2 special kinds of sequences. Okay, one is called arithmetic. You can also say arithmetic, it's pronounced either way. I say arithmetic when I'm talking about sequences. And the other one is going to be what we call geometric. Okay, but let's start with arithmetic. In an arithmetic sequence, it follows a Very special pattern. The pattern is that you are adding to get from one number to the next. So we've already seen some examples of arithmetic sequences today. Okay, so pattern in an arithmetic sequence, you are adding to get from one number to the next. The number that you add each time, we're going to call D. Now, D stands for common difference, which is a little strange because you might think with common difference kind of sounds like subtracting. But if you weren't sure what you were adding each time to get from one number to the next, take any number and subtract the one that comes before it. That will tell you what you are adding each time. So if you do 9 minus 7, what do you get? 2. How about 7 minus 5? 2. 5 minus 3? 2. Okay, they all come out to 2. That's why it's called a common difference. So take a term, subtract the one that's directly before it, and that will tell you what you're adding each time. So this is well, what kind of formula is that? Where you're adding something to the one that comes before it. Something.
Recursive?
Recursive, yeah. So this is recursive. What we want is explicit. That is the explicit formula for an arithmetic sequence. So now we don't have to try to guess, is it like times 3 and then minus 1, or is it times 5 and plus 2? You're not going to have to guess anymore. The only thing you have to know, two things you have to know to write down an explicit formula for an arithmetic sequence is you need to know the first term and you need to know what you're adding each time. So we're going to go back and try that on one we've already done and see if it works. Remember that n is a positive integer. Capital Z written like that, that's the symbol for an integer. So this means n is a positive integer. No negatives, no fractions, no decimals, no zero. Okay. So let's go back to this one. We were able to figure out the pattern here was 5n minus 2. I gave you guys some time to look at that. But let's see if we can figure this out without trying to guess. Right? We're going to follow the formula and see what happens. So a sub n equals first term. What was the first term in example 3? 3. Plus n minus 1. And d is what we call the common difference. It's what you add each time. What did we add each time? 5. When you have a 5 on the outside of parentheses, what do you do with that? Yeah, you have to multiply. You've got to distribute it. Because right now, that formula doesn't look like what we got. But let's simplify and see what happens. What's 5 times n? 5n. And what's 5 times negative 1? Negative 5. So we have 5n. And then what's 3 minus 5? Negative 2. There you go. 5n minus 2. And that's exactly what we got. So now we've got a way to figure that formula out without having to try to guess. Okay, I think that was it for that. Yeah. All right, so let's try this one. It says find an explicit formula. With what I've given you there, that would actually be impossible. What do I have to tell you that I didn't tell you?
First term.
Yeah, you need the first term, because this just says add 3 to the one that comes before it. We don't have anything, so what are you going to add 3 to? So let's define the first term to be 6. Okay, so first term is 6. Okay, so take a minute and see if you can figure out the explicit formula for example 5. Okay. So first thing we want to do is start out with what the formula is. Can someone tell me what's the pattern for an explicit formula? You don't have to fill anything into it. Just tell me what the pattern is.
A1
Yep.
plus n minus 1.
So first term plus n minus 1, and then what'd you say after that?
And then D.
Times d. Yep. Times d. Okay, now we got to fill in 2 things. You never fill in for the n when you're finding the formula. You only fill in for n if it says find the 28th term. Then you'd fill in 28 for n. But what's the first term here?
6.
6. And d is the number that we are adding each time to get from one to the next, which is 3. Yep. Okay, you do want to simplify that as much as you can. So what property are we going to use with the 3 on the outside of the parentheses?
Distribution.
Yep, going to distribute it. And what do you get when you distribute that 3?
3 minus 3.
3n minus 3. I usually put the term with n in the front. And it's going to end up being 3n plus 3. Yep. There you go. Any question on that one? All right, now we can check it. If we plug in 1, let's make sure we actually get the first term. What's 3 times 1? 3. And what's 3 plus 3? 6. All right, good. So it's always a good idea to check it and make sure that it actually worked. Okay, let's try this one. This one says the first 2 terms in an arithmetic sequence are -8 and -2. So let's find a formula for the nth term and then find the 5th term. Okay, so let's start with our formula. Serenity, can you remind us again, what's the explicit formula for an arithmetic sequence?
A to the first.
A sub 1.
What?
A sub 1. Yep, so A sub 1.
Plus n minus 1 times d.
Plus n minus 1 times d. Okay. Ruben, what's my first term here?
1.
Well, that's what we call the first position, but that's not the number in the first position.
-8.
-8. Yep. Plus n minus 1. And what would be our d value here? No, not 5. Gianna, can you help us out? What would be our d value? Six. Yeah, you're adding 6 each time. -8 plus 6 gives you -2. Okay. So now we just have to simplify that. If we multiply 6 times n, we're going to get 6n. And then what's going to be, actually I got a box right here. 6n. And then what number is going to be on the end of it? -14, right? Because we're doing -6, take away 8 is -14. Okay, so now we've got a formula for the nth term. And now, what are we going to do? What number do they want us to plug in for n? 5. So we're going to plug in 5. What's 6 times 5? 30. Minus 14 gives us 16. Okay. So there's our nth term. Well, I'm sorry, that's our 5th term. 16. Okay. Any questions on how we got the formula? Or why we plugged in the number 5 and how we got 16? Okay. Let's try this one. It says find a formula for the arithmetic sequence. They've given us enough information, but what's a little different this time? We don't have the first term, but we got the 13th, or we got the 3rd term, and we got the 8th term. So somehow we have to work backwards to get the first term. So the way we can figure it out is to get from the 3rd term to the 8th term. How many steps is that?
5.
It's 5 steps, okay, 5 jumps to get from the 3rd term to the 8th term. And what's the difference between 13 and 3? 10. So we're going down 10 units, and we're doing it in 5 jumps. So we're going down how much each time? 2. So this would be 11, 9, 7, and 5. Now we can work our way backwards to get the first term. If we go down 2, what would be the second term? Up 2, and then the first term. There you go. So now it's just like the last problem. We have the first term, and we have what we're adding or subtracting each time. Okay. So what's our first term? 17. And what are we doing each time? Subtracting 2. That means D has to be a negative number. Okay, so A sub n equals A sub 1 plus n minus 1 times D. We'll do that out, and that will be our formula. Negative 2n. What's negative 2 times negative 1? Positive 2 plus 17? 19. There you go. And this time they didn't want us to predict any other pattern, any other terms. They just said find a formula, so we're done. Okay. So any question on arithmetic? You can call it an arithmetic sequence, or you can also call it an arithmetic progression. It means the same thing. Okay. Geometric. Okay. Geometric is a little bit different. So in a geometric sequence, the pattern isn't that you are adding each time, it's that you are multiplying each time. So for example, if you had something like 2, 4, 8, 16, 32, I'm not adding the same number over and over there. If you just looked at the first 2, you might think, oh, maybe you're just adding 2. But then when you look at the next one, I didn't add 2. That would have got me to 6. Okay, I'm doubling each time. Okay, that's called a geometric sequence or geometric progression. So to find a particular term that you want to know, take the term that comes before the one you want to know and multiply it by r. Okay. So this is the term before, and this means times r. R is called the common ratio. Now again, it might seem kind of weird. It's kind of like, why do we use the term common difference when we're really adding each time? So why do we use the term ratio? Ratio makes you think of a fraction when you're multiplying. Well, look at this pattern. let's take a term and divide by the one that comes immediately before it. What's 24 divided by 12? 2. What's 12 divided by 6? 2. What's 6 divided by 3? 2. So if you are not sure what you're multiplying by each time, then pick a term and then divide by the one that comes immediately before it. If you can't go to any term before it, you got to go to the one immediately before it, and that'll tell you what you're multiplying by. Okay, so this is recursive, not the formula we want. We want explicit. That is the explicit formula. So it relies on two things. Just like the other explicit formula relies on two things. One of them is the same. You need to know the first term. But the other one is different. You need to know R. So it's a sub 1 R raised to the n minus 1 power. Okay, that n minus 1 is a power. All right, so let's try an example of a geometric sequence, and then that'll be it. So it says find an explicit formula for the geometric sequence. I do have to tell you that it's geometric in this case. If I didn't, you wouldn't have enough information. Because to get from -6 to 12, maybe I'm multiplying by something, or maybe I'm adding something. I don't have enough terms to tell, but since I said geometric, then you know which formula to use. Okay. What's the formula for a geometric explicit sequence?
A1 times R to
A1 times R to the
negative or n minus 1
n minus 1. Okay. We don't have the first term here, but we can figure it out. How do you get from -6 to 12, and it has to be multiplying because it's geometric? You times by -2. So if you went to the fourth one, what would that be?
Negative 24.
-24. But we don't want to go to the right. We need to go back to the left one. So if you times by -2, then do the opposite of that, and it'll tell you the first term.
3.
3. Yep. Okay. So we know the first term is 3. And R is what you multiply by each time.
Negative 2.
You're multiplying by -2. And that's it. Okay, we can't simplify that. 3 times -2 to the n minus 1. Don't put like -6 to the n minus 1. That doesn't work. You have to just leave it as 3 times -2 to the n minus 1. Well, that's it. Let's try it. Let's see if it correctly predicts the third term. What's 3 minus 1? 2. What's -2 to the second power? 4. And what's 4 times 3? 12. Perfect. Okay, so I always like to check it, make sure that it works. If it doesn't, then something's wrong. Any question on that? Okay. So that's for tonight on the 589. It's all odd except the 14. That's the only even one. But 1 through 5 is odd, 9 to 13 is odd, and 17 to 27 is odd. Okay, that also finishes 11.1, so that's the first section for this week. Tomorrow we'll do part 1 of 11.2, and on Wednesday we'll do part 2, and the plan is to do the test on Thursday.